Hello. In this video, we will look at the process of recovering data from virtual machine disks in .raw, .vmdk, and .qcow2, as well as ext4 file system-based directory storage. We will analyze the most common data loss scenarios, such as accidental deletion of files on a virtual machine and of the virtual machines themselves, data corruption due to disk failure, server, PC, or NAS hardware malfunctions, as well as software crashes of the Proxmox VE OS caused by updates, critical errors, or deletion of the OS. We will show how to diagnose disk status, connect drives directly to the PC, and recover data using specialized software. The described methods and tools are universal and suitable for Windows, Linux, and Mac OS. KVM integrates directly into the Linux kernel, turning it into a hypervisor. This allows virtual machines to interact directly with Intel VTX or AMD V CPU hardware extensions and operate at near-native performance compared to physical servers. QEMU assumes the role of an emulator that provides the virtual machine with necessary hardware, such as network adapters, graphics cards, disk controllers, and USB ports. Furthermore, using optimized VirtIO drivers allows the system to work much faster, guaranteeing a full-featured environment for the guest system. One of the main advantages of this combination is extreme flexibility when working with storage. QEMU supports the advanced qcow2 virtual disk format, which allows thin provisioning and encryption. In addition, the system fully understands formats from other platforms, such as RAW, VMDK, or VDI, making KVM and QEMU an ideal solution for seamless migration of virtual machines from other ecosystems without the need for time-consuming file conversion. At the enterprise solution level, this tandem unlocks powerful functionality. It supports live migration, allowing a running virtual machine to be moved between physical servers without loss of connection or rebooting. Another critically important feature is PCI pass-through. Thanks to this technology, you can pass through a real physical GPU or network adapter directly to the guest OS, achieving 100% device performance for complex computations, rendering, or gaming. Before starting software recovery, we need to properly connect the server drives to the PC. This can be done in several ways. The most reliable option is a classic connection via SATA directly to the motherboard. This guarantees maximum read speed and minimal latency. If there are not enough connectors on the motherboard for the entire array, a PCIe to SATA adapter is a great solution that will allow you to connect additional drives. If you don't want to disassemble the PC case, you can use external USB docking stations or adapters. But remember, scanning speed over USB will be significantly lower, which will noticeably affect the time required to process large data sets. And the most important rule, you should always consider creating a disk image. This is especially crucial if your storage drives have bad sectors, make unusual noises, or carry a risk of further degradation. In this case, the software will work with the virtual copy without putting load on the damaged physical drive. Among all storage types in Proxmox, the ext4-based directory option is the easiest to understand. Its main feature is that it uses a standard folder hierarchy rather than complex block devices such as ZFS or LVM thin. In fact, it is a regular file system where qcow2 or RAW virtual disks, bootable ISOs, and backups are stored as ordinary files in a clear directory structure. Thanks to this transparent architecture, this storage type is as user-friendly as possible. Let's imagine a situation. As a result of a server hardware failure or hypervisor software error, the structure of such a storage was damaged, or an important folder was accidentally deleted. Despite being a server infrastructure, it is precisely thanks to this simple file architecture that data rescue here follows a classic and straightforward algorithm. Let's look at the procedure in case of a server hardware or software failure. A hardware failure most often occurs due to a motherboard failure, controller breakdown, or power issues, where the server simply stops turning on, even though the drives themselves remain physically intact. A software failure, in turn, usually happens due to an unsuccessful Proxmox update, corruption of system libraries, or accidental deletion of hypervisor configuration files. In both of these situations, the consequences are the same. The system refuses to boot, the management web interface becomes inaccessible, access to virtual machines is completely blocked, and you are left alone with the data on the drives without the ability to start them normally. To resolve this problem, we will use Hetman partition recovery. This is a proven solution that thoroughly understands the architecture of Linux partition schemes, can perform deep drive analysis, and correctly reconstruct the original directory tree. As always, you'll find the link to download the software in the description below the video. To find the lost data, select the automatically identified logical volume labeled ext4 in the software and start the scan. To begin with, we recommend using the fast scan mode. However, if the file system structure is severely damaged and the fast scan gives no results, use full scan mode. Once the program finishes its work, open the found directory storage and you will see the original folder structure of the ext4 file system. Since in this specific case, the virtual machine files were stored on the drive, we'll find them in the ext partition section by navigating to the images folder and opening directory 100. Now simply select the required virtual machine images, click the recovery button, and specify the path to save them to a safe target drive, making sure there is enough free space for the data. The RAW format is the simplest type of virtual disk, representing an exact byte-for-byte copy of the data, which immediately pre-allocates all assigned space on the server drive regardless of actual usage. Due to the absence of a complex internal structure and compression, this format delivers maximum performance and is the most convenient object for recovery algorithms, which scan it like a standard physical disk. The qcow2 format is the most modern solution for the QEMU environment, featuring dynamic memory allocation technology. That is, such a disk grows physically only as new files are written by the guest system. It supports snapshots and encryption to optimize resources, but its multi-level architecture requires recovery utilities to perform deep analysis of allocation tables when rescuing data after a hypervisor crash. The VMDK format was created for the VMware ecosystem, but thanks to its versatility, it is fully supported in Proxmox, often indicating successful migration from other server platforms. It allows flexible storage management and has an open structure, enabling recovery programs to mount such images for instant file extraction without starting the VM itself. After successfully scanning the directory ext4 storage, the program will display all found virtual machine files. To start working with their contents, select the required images, click Recovery, and specify a safe location to export these files to your computer. Once the saving process is complete, you can proceed to step-by-step mounting of the disk images in Hetman partition recovery. Mounting VMDK and qcow2 formats follows an identical algorithm. Click Mount Disk on the toolbar. In the Disk Image Type window, select VMware Workstation to work with a VMDK file. In the next Select Folder window, simply specify the path to the folder where you just saved this virtual disk. The program will automatically analyze the specified directory and display the found image under Virtual Machine Images. You only need to select it from the list, and the mounted disk will immediately appear on the main screen, completely ready for data search and queries. To mount a qcow2 format image, the procedure is completely identical. After opening the Mount Disk window, simply choose the QEMU option under Disk Image Type, and then similarly specify the path to the folder containing the saved file. As for the RAW format, the procedure looks slightly different. Having opened the Mount Disk window, you need to find the Standard Disk Images section and select the Raw Disk Images option. After that, in the Browse window, simply select the saved virtual machine file itself. The program will instantly mount it and display it on the main screen, fully preparing the disk for scanning and recovering lost files. In this example, we will demonstrate the process of recovering information from an already mounted qcow2 image. Select this virtual disk on the program's main screen and run the analysis. To start, as usual, we recommend using the Fast Scan mode. It will quickly analyze the contents of the image and display the results on the screen immediately. If the file system structure turns out to be severely damaged and the fast scan doesn't yield the desired results, use Full Scan mode. Once the scan is successfully completed, open the found storage. The program will correctly recreate the original directory structure, showing both existing and previously deleted data. Now, simply find the required folder with the test files, select them, click the Recovery button, and specify a path to save them to another safe working drive. Deletion of a virtual machine in Proxmox most often occurs due to human error and leads to immediate loss of configuration files and RAW, VMDK, or qcow2 virtual disks, since the system does not have a recycle bin or trash. However, data is not physically overwritten immediately. The file system merely removes their entries from the allocation table and marks the space as free. Therefore, the main rule for successful data rescue is to immediately stop any writing activity on the storage to avoid overwriting residual data and to start software recovery procedures as soon as possible. To resolve this issue, we will use Hetman partition recovery. After connecting the drive, the software will automatically detect the ext4 logical partition where the deleted virtual machine files were stored. Select this partition and run Fast Scan mode. Upon successful completion of the Fast Scan, the program will display the original directory structure. The remaining steps are already familiar to you. In case the required files cannot be found visually, we recommend using the search tool by entering their exact name or size. Now, all that's left is to select the required virtual disk images, click Recovery, and specify a path to save them to a safe working drive, having first ensured there is sufficient free space available for this data. This brings our guide on data recovery from a Proxmox environment to an end. We step-by-step covered the process of recovering RAW, VMDK, and qcow2 virtual disk files from ext4 storage. If this video helped you solve your problem, support the Hetman software channel with a subscription, as we regularly release detailed guides for the most complex data loss cases. We look forward to your questions in the comments. We are always in touch. Thank you for watching, and may your servers run without fail.